Welcome to Slight Reliability, learning SRE one day at a time. I'm Stephen Townsend. Welcome back to Slight Reliability. I'm Stephen Townsend, and this is the show where we learn SRE one day at a time. A couple of weeks ago, I interviewed Ruben Hakopiean from Kubevious about Kubernetes, and we had a great conversation about all aspects of Kubernetes that relate to SREs. I took the recording and I cut it together, but unfortunately there were some audio issues with that, so Ruben and I decided not to publish that interview, which is a real shame. So instead today I'm going to cover the same topics that we talked about in the interview and supplement that with some experiences that I've had and some learning that I've had on the job recently, all around the theme of Kubernetes. Now, I don't often talk about a specific technology, especially for a whole episode, but Kubernetes is one of those things that a large number of SREs all around the world are using and operating and monitoring all the time. And so I think it's fairly applicable to a lot of different people. And for any SREs who haven't worked with Kubernetes yet, I'm sure that you will in the near future. It is becoming the de facto standard for containerized workloads and to orchestrate those. The other reason I want to talk about Kubernetes is that I've been working a lot with it recently. We have been standing up this independent observability or monitoring platform with an IAG, which contains various components, Grafana, Prometheus, Mimir, which is Grafana's high-performance metric storage, and we've been hosting all of this on Kubernetes. And it has been far more complicated than I expected. But also, there's been a lot of great learning. The first question I asked Ruben is, why is Kubernetes so popular? Why is it so commonly used? And his answer was that it's become the cloud native standard for running and orchestrating container workloads. All the public cloud vendors are behind it. They provide services which make the barrier to entry very low. So I think that pretty much sums up that question. The second thing we talked about is if you're a person who wants to learn Kubernetes and get some hands-on experience, what can help with that? And we really talked about tools. So there's one from my experience. So I've been using Docker Desktop to play around with containers and develop containers on my own laptop. Now, Docker Desktop has a Kubernetes mode. You literally just go to options and click a button and it starts you your own little cluster. And it works really well. It is the most reliable way that I've found to run a Kubernetes cluster on my own laptop. Alternatively, Ruben suggested Kind, which is another tool for running a Kubernetes cluster locally. By the sounds of it, it is very, very quick. You can spin up a cluster in literally seconds. So if having speed and performance is a thing that you really care about, have a look at Kind. Now, I wanted to know whether there were some common kinds or types of incidents or issues which occur in Kubernetes environments to keep an eye out for, from Ruben's experience and also thinking about my own experience. And one of the ones that Ruben mentioned is actually happening to me right now. So let's say you have an application, you're running it in a container. That application, you're passing in a config file which sets all the details of how that application should run. And that config file is being passed in as a config map, which is a structure or a resource within Kubernetes. Now, if you do a deployment and you change that config map, unless you actually restart the application, it's not going to pick up the new configuration. So you might do a deployment, not see any change in your application, and you might think, oh, it hasn't worked, it hasn't deployed. It has, you just haven't gone and restarted the application. Now, that is exactly what is happening to me right now. We have Prometheus deployed in Kubernetes, and we pass in the configuration, which is very important because it has the scrape configuration, the scrape config. And that tells Prometheus all the different metrics endpoints to collect from. And I change this quite often. And at the moment, it's quite annoying because I've only built automation to completely deploy or completely undeploy all of our components. And that's inefficient and it's slow and it creates a 1 or 2 minute outage. So I'm going to need to build some kind of pipeline which just deploys Prometheus and restarts the application to pick up the new config map that we've deployed. Now, in a Kubernetes environment, everything is described in a manifest file. So manifest files are just YAML configuration that tell Kubernetes what to create and the state that you would like it to be kept in. Now, these configuration files, these YAML files, it's very easy to make a mistake. So you can treat these YAML files like code, and you can run a static analysis tool over them to check for common issues, which is something I don't do right now. But that is exactly what Ruben's product, Kubevious, does, and many other products out there as well. So that's the other really common issue in Kubernetes, is having a problem which you didn't pick up in your manifest files. On the topic of monitoring, so let's say you are hosting an app in Kubernetes. What do you monitor from a Kubernetes perspective? Now, I'm really not an expert and I don't have all the answers. I do like to think about it at different levels, and like with any other monitoring or observability, being that keyword that people use these days, the first thing to check is, can the customer consume the service or use the application? So as the application level monitoring is the most important thing, I think. So moving on to Kubernetes and how we monitor that, the first thing I think about is pods. So although pods are the smallest unit which Kubernetes can deploy, there isn't always a one-to-one relationship between pods and the containers that run in them. But I think in many respects we look at similar things when we monitor a pod or a container. How utilized is the container? And within the context of containers, I think what we really want to know is whether our pod or container is being throttled because it's exceeding its allocated CPU time. The other thing that I've been looking at when I deploy and monitor my app, which is running in Kubernetes, is the state of the pods. Are the pods running? Are they in a terminated state or an error state or an unknown state? Are they still starting up because I just did a deployment? That's useful information. It helps me track my deployments, and it helps me monitor whether or not at a Kubernetes level my app is healthy. As for nodes, I've been treating them in my head a bit like a traditional server. And I've been tracking the 4 key hardware resources, which are CPU, memory, disk, and network. I don't know if I'm missing something there, but I think of a node as an abstracted idea of a server which runs a bunch of Kubernetes or container workloads. Now, I've never actually run a Kubernetes cluster or series of clusters. I think if I was doing that, then I would need to do a lot more research into master nodes and worker nodes and how they communicate and all the various components of Kubernetes and how they are interacting with each other. I haven't gone to that level of detail. I've recently learned about Conways Law, which apparently is common knowledge in the industry, but I only just learned about it. And the idea behind that is that the architecture of the software which an organization is building and has is related to the structure of the organization. So I asked Ruben, what does it mean for organizations that run Kubernetes? His thoughts were that Kubernetes is no exception, and that organizations that are running Kubernetes workloads, the developers and the infrastructure teams, there's a much more blurred or thin line between them. Developers tend to be more invested and involved in the running of their code. And that can lead to developers either being more thoughtful about their code and how it performs and how reliable it is, or at least having a closer relationship with those people who run their workloads, whether those are SREs or ops engineers or infrastructure engineers. So that can only be a good thing. Now, I work for an insurance company, so there's a certain element of risk about running workloads in the cloud. It does happen, but there are processes that need to be followed. So all of my Kubernetes experience to date has been about hosting and running Kubernetes workloads on on-premise clusters, which are built and managed by other teams. So I asked Ruben about cloud-native Kubernetes services like AKS, EKS, GKE, and are they as good as they sound? And his thoughts were, absolutely, they are awesome. They take all of the burden of having to manage the underlying hardware and infrastructure, so you can focus on more important or more interesting work, which is more about the application and running that effectively. So I think that's great, and I'm looking forward to, in the future, utilizing some of those cloud native services. Last thing is that if you've been seeing my posts on LinkedIn, I have been very reluctant to use Helm to deploy my Kubernetes workloads. And I didn't really understand Helm very well. I only saw the templating, which seemed massively heavy-handed and complicated for what I wanted to do. But it turns out, from what Ruben was saying, that Helm does a lot more than just templating. It helps prevent leaving dangling resources within your clusters. It keeps things clean and clear and consistent. And I didn't know that. So after hearing that and having that discussion, I'm much more open to the idea of Helm, and I'm going to go with the flow and use it when I need to. I mentioned at the start, I'm helping to build, my team is building this observability platform, Grafana, Prometheus, Mimir. Now, Mimir is fairly new. It's an open source product being created by Grafana Labs, and we're trying to integrate it. It's designed to be integrated with object storage in the cloud, particularly S3 and the Google object storage, which I don't know much about. We're trying to implement it with an on-premise object store, which has an S3 compatible API, and it turns out that that's not working so well. So I've been spending a lot of time going through logs and monitoring and changing settings and trying to figure out what's going on. So that's been challenging and fun and frustrating at times, and it kind of feels like I'm doing some real SRE work in a way, which it sounds self-deprecating to say the work I have done previously wasn't real, but there's something satisfying about doing some hands-on technical work now and again and getting to the bottom of some problems and opening up cans of worms, which maybe no one expected. And that's all from another episode of Slight Reliability. Thank you so much for tuning in. I'll see you next week for more SRE goodness. See you next time.